So let's review the definition of differentiability. So first of all, in order for a function to be differentiable, it has to be continuous. Okay, so always work on that part first. Is the function continuous? The second part is the limit part. So remember the left-hand limit as x approaches a or c or whatever it is of f prime, all right, has to equal the right-hand side of f prime. So in other words, the slope on the left has to equal the slope on the right. And remember, when I say f of x is continuous, there's a three-part definition of continuity here that you need to know. So I just wrote f of x is continuous because we've all gone through chapter 2, so we know that there are three parts. F of a has to exist, the limit as x approaches a has to exist, and the f of a has to equal the limit as x approaches a of f of x. So let's start with the continuity. So does f of 1 exist? Yes, f of 1 does exist. If you plug in 1, you get 3 minus 1, which is 2. And you are plugging that into this one because its x is less than or equal to 1. So first, f of 1 works. Now let's find the limit as x approaches 1 on the negative side. So that would be 2. And the limit as x approaches 1 on the positive side. Make sure to use correct limit notation. You have to write the function here. And that is also 2. And since f of 1 equals the limit as x approaches 1 of f of x, f is continuous. So make sure you know your three-part definition of continuity. Okay, so f is continuous. So now I need to find the derivative and see if the left-hand side of the derivative equals the right-hand side. In other words, do the slopes match up? So this is what you do. You write f prime of x equals, and then you just take the derivative of both parts of your piecewise function separately over the same domain restrictions. So the derivative of 3x minus 1 is 3, for x is less than or equal to 1. The derivative of x squared plus 1 is 2x, for x is greater than 1. And then the limit as x approaches 1 on the negative side of f prime. Okay, so this is one of the reasons that we always have to write our function next to our limit. It's like we can't, sometimes we're taking the limit of a function, sometimes we're taking the limit of a derivative. So you just want to make sure that that's consistent. So on the left-hand side, we get 3. On the right-hand side, and you do have to write these separately as left and right-hand limits for full credit on the AP exam, by the way. The right-hand limit is, if I plug in 1, I get 2. So because the limit as x approaches 1 on the negative side of f prime does not equal the limit as x approaches 1 on the positive side of f prime, f is not differentiable. At x equals 1. All right, find a and b values that make f of x differentiable. So in this case, we are kind of working backwards here. We are going to make sure that the function is differentiable by requiring f of x to be continuous and by requiring the derivative to have left and right hand limits that agree. So let's start with making sure f of x is continuous. So if f of x is continuous, then that means if we plug negative 2 in for x, that needs to equal negative 2 plugged in for x on the other side. So this is very similar to what we did in chapter 1 and 2, where we were trying to figure out what values of a and b make f of x continuous. So we're going to start similar to that, and I do recommend that you go ahead and just simplify now. So negative 6 plus a is equal to 4b. Minus 10 plus 4 is minus 6. Did I do that right? Yeah. Okay. So then add 6 to both sides. I get a is equal to 4b. Okay, so I can't just stop there. And that is a constant issue, is students just kind of stopping and saying like, well, okay, now I'll just plug in, okay, if b is 1, then a is 4, and that works. That makes the function continuous if b is 1 and a is 4, but that doesn't make it differentiable. So what we need to do now is find the derivative and make sure the left-hand limit of f prime is equal to the right-hand limit of f prime at x equals -2. So find the derivative of 3x plus a. Now a is a constant, so the derivative of a constant is 0. The derivative of 3x is 3. And then on the other side, the derivative of bx squared, so 2 times b x to the first, and then the derivative of 5x plus 4 is just 5. That's if x is greater than or equal to -2. Please make sure you write your entire domain restrictions. Okay, so now let's show that the left-hand limit is going to equal the right-hand limit. So that would be 3 on the left-hand side is equal to 2 times b times, and then x is -2, right? And then we can solve for b. So subtract 5, we get -2 is equal to -4b. Just move up here. -2 divided by -4 is equal to b. So b is equal to 1/2. Since a is 4 times b, a is equal to 2. So b is 1/2 and a is 2 in order to make f of x differentiable. So remember, differentiable means f of x is continuous, and then the left-hand limit is equal to the right-hand limit at whatever the domain separator point is.